4, 3.
Wait, can you make it louder than that? Like a
Slap it.
Okay.
Slap it.
I'll make it work. Thanks, smartass.
You're listening to Coding Blocks, episode 72. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
And check us out at codingblocks.net where you can find show notes, examples, discussion, and more.
Send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks or head to www.codingblocks.net and find all our social links there at the top of the page. With that, I'm Alan Underwood.
I'm Joe Zach.
And I'm Michael Outlaw.
All right. First up, a little bit of news here. We're starting with the reviews. Alan, you want to tell us about the iTunes reviews?
Yep. So we've got Dev Material, BT, and D's, and you know who you are. Brome, CS Olson, and we've got some Mandarin here. That was fun. It actually translates to Paul Bear. I plugged that in to translate. That was good. The Real Mr. Nice, B. Efferman, and Jaramillo Developer.
And on Stitcher, we have Giorgio33, Jenna Tulls, Blue Wilson, Daniel Holter, and Jimmy Cliff.
All right. And on Podchaser, we got RM Quist. Thank you very much.
Yes, very much indeed. And so I wanted to give a quick shout out here. So being that we're all into programming and we like puzzles and things like that, like that's what we do is we solve puzzles. My wife and I have gotten into where we really like doing escape rooms. And if you're ever up in the Kennesaw area, there is a really good one. And this guy, he's trying to live the dream, right? Like he's done his own business here and created this escape room, and it's called Mindscape Rooms. And I highly recommend it. Like all kinds of cool little electric gadgets, like you do something over here and it unlocks something over here. Like it's just really fun. They did an excellent job. So if you're in the Kennesaw area, definitely go check them out. It was a ton of fun.
Did you escape?
Of course we did, man. Come on.
How many hints did you get?
We used our hints. Like, that's no doubt. But that was it. But we did get out. It was a lot of fun.
Yeah, those can be really hard.
Some of them are incredibly difficult, but it's perfect for puzzle solvers, right? Like it makes your brain work in a different way, which is awesome.
So just a heads up for anyone who's not already taken advantage of this, Pluralsight is giving away for free 3 months with a Microsoft Dev Essentials account. So not entirely sure if this is still valid, but we're going to include the link in the show notes, and hopefully it'll still be a thing. This was sent to us by our friend Viv, who's the co-organizer for SwanseaCon.
Yep. And Dev Essentials comes with a whole slew of its own stuff, like, cloud access, developer tools, all that. So you get a bunch of other stuff with it, but having 3 months is a pretty good way to start your new year out. Yeah.
Yeah. And it's Microsoft Visual Studio Dev Essentials. So, you probably have an account anyway. And it's really nice. It's really free. And 3 months of Pluralsight is pretty amazing. You could watch, like 10% of the videos in that time if you really tried.
Yeah.
10%.
They have a ton now.
Yeah, they do.
All right. And speaking of Pluralsight, if you decide that you want to sign up for it, and you also want to support the show, you can go to codingblocks.net/resources. And we've got a bunch of affiliate links and just other things that we kind of like there that we get a lot of questions about. And if you go to that page, click on some stuff, you'll be helping support the show and also be getting, cool stuff that you want anyway. So check it out. That's codingblocks.net/resources.
All right. Well, this is it. This is the episode you've been waiting for. We're talking about component coupling, where Uncle Bob is going to introduce 3 new principles to us to help us define stability and abstraction and show us how we can mathematically graph the quality of our code and finally explain to us how independ works.
True that. I don't know about you guys, but I really enjoyed this particular chapter.
Yes.
I think you guys will hear it as we get into it, but this one had a ton of meat in the meat and potato department. So here we go. The first one we're going to kick off with is in the component coupling is acyclic dependencies principle. And the first thing that they say here is allow no cycles in the component dependency graph. And to several of you listening, I'd venture to say a lot of you listening, you're going to be like, what does that even mean? The whole a cycle in your dependency graph basically means it can't come back to itself, right? Like there's no point where you can follow the arrows of one thing pointing to another and it circle back to you. So that is a circular dependency is what you also call it when you're talking in programming terms. So that's what they're referring to when they say no cycles in the dependency graph.
Yeah, basically draw all your components and with arrows of which components depend on another component and keep drawing that one. And if you have any path that can circle back on itself, then you have a cycle.
Yep. Yeah. And back on itself isn't necessarily meaning just pointing to itself. It could be just further up 2 levels in the chain, right? And then come back down.
Yeah, if you can eventually get back to it.
Yep.
Now, I got to ask a question. How is this even possible? How can you have a cyclic circular dependency and it compile?
We've definitely seen it. Haven't we?
Where it compiles?
I think so.
I know a C# will kind of yell at you about stuff like this. I was just kind of wondering the same thing. I saw the graphs in the chapter and kind of made sense, but now I actually think about trying to compile, I don't know how I could reproduce this unless we're talking about total disparate, systems.
Well, the one thing that I was thinking about, it was interpreted languages. Those were the only kind of environments where I was thinking maybe because you're not pre-compiling, you're not doing things like includes or imports, you're just figuring it out at runtime, what's necessary. And I was like, okay, maybe in something like that. But in any kind of compiled C, C++, C#, Java, I was a little confused as to how you could get into that scenario. But yeah, we can go on.
Yeah, I can't think of how you could do it. It seems like I've seen it. Maybe I'm wrong. Maybe I am thinking of JavaScript or Ruby or something like that. But yeah, anyways, the what they call here is the morning after syndrome, which is interesting. It's kind of funny. They talk about when you work late one night and you're busting your tail, you get something working, and it was perfect that night. You left at midnight, all's well. You come in the next morning, first thing you pull in your latest code, and it's not working anymore, right? It's happened. Everybody who's worked on any kind of teams, this has happened to them at some point.
That is the most surefire way to ruin your day right there.
Is.
Because you go home, you stayed late that night anyways working, and whether it was because you had to or you wanted to or whatever the reason was, by the time you left, you're like, yes, it's working. I did it. It's done. And then you come back in the morning and you're like, yeah, you got this big smile on your face, ear to ear. And then you pull the latest code down and then it doesn't compile. You're like, what? What just happened?
Yep. And a surefire way to get this to happen is to have a long running branch. Go, spend a week, 2 weeks working on some big feature, and then you go to merge it in, and the ground has changed underneath you. Everything is different. So now you can't merge it in. So now you spend another day, getting up to date. Oh, but now they don't want to merge it in because some other stuff's going along. There's going to be some sort of release. It's it's considered risky now that you've had a couple conflicts. So let's push it off another day. And next thing you know, you're looking at week 3. And it just gets harder and scarier and more difficult as each day passes.
I found this very interesting that he said that this can happen when too many developers are working in the same files or project.
Yep.
It was almost like not only is the book talking about how to structure and organize and architect your code, but in a statement like that, he's also talking about your teams and the organization of your development. The developers within your company,
how they should work. Yeah. And they also say this makes it extremely difficult to get a build out, which is what Joe just referenced, right? Here it is. It's Friday. You're supposed to be getting something out, and all the stuff that was working Thursday night is now back into a state of, probably disarray and maybe not even testable at that point, if that's the case, right? So, yeah, there's all kinds of things, and they say there's two types of solutions that have evolved, and we're going to talk about the first one now.
Yeah, and this was curious too because he says that both of them evolved from the telecommunications industry, and I didn't have a chance to go back and dig into where that was, but I did find that super curious. I want to go back and try to remember to look that up. But if anyone is familiar with where this came, its origins within the telecommunications industry, I'd like to know. And the first of that was the weekly build.
I bet nobody's heard this one before.
Yeah. So basically the idea here is that, because the build was such a hassle and merging in everybody's code and whatnot, it was so burdensome that, that became such a burden that it would take an entire day. So the idea was, well, we'll let all the developers work for 4 days and give them 4 solid days, uninterrupted time. They can just do their own thing in their own code base, their own repository, whatever, locally, do their development. And then we'll worry about integrating in with everybody else, with everybody else's components and code and whatnot at the end of the week. So we'll do that on Friday. We'll save it for 1 day out of the week, and we'll figure out the problems then.
Yeah. I've never, I haven't seen it weekly, but I've seen it in kind of like larger projects where you've got multiple teams. And so you say the installer team is kind of off doing their own thing for a sprint or some sort of cycle. And the UI team is doing their own thing. And they're kind of like either mocking out those dependencies or just kind of ignoring or whatever. And then you've got some sort of, some other team that's doing something separate. And then at some point you kind of try to bring them all together and do some sort of, a big test. And it's always terrible. And it's like weeks of terrible. Like a large percentage of the time you spent developing, terrible.
Yeah, and it doesn't get better. Like they say here, the problem is that Friday build starts trickling into Saturday, right? Like, oh, we got to get this build out. So then people end up, they probably stay all day Friday till 7, 8 o'clock at night, and then they're back in Saturday morning and try and wrap the thing up. And then eventually that breaks down, right? And then it starts taking all day Saturday and starts creeping into Sunday, and then people will say,
well, it starts backing up because, you're willing to accept that one Saturday.
Right.
Right. You're like, oh, fine, whatever. It's once in a blue moon. Right. And then there's that second and that third Saturday. You're like, whoa, hold on. I'm seeing a pattern here.
Right.
We got to start this process on Thursday. So now all you developers, you get 3 solid days, and we're going to take 2 days to do the build.
And
or you like expand out, like I kind of talked about, where it's like, okay, now we do the first 3 weeks is development and 1 week is integration, or 2 weeks development, 2 weeks integration, or you can kind of set that dial a little bit more granular. But both are, it's just crazy.
Yeah, it's ridiculous because then your productivity takes a major hit, right?
Yep.
Like you're not developing, you're not creating stuff. Now you're just dealing with garbage that has to all flow together at the end.
Yeah,
and the bigger it gets, the worse it gets.
Yeah, and I was curious though too, and maybe this is where the telecommunications part came from, but like I've never worked in an environment where we only did a build once a week.
Mm-hmm.
Have you guys? I mean, I know Joe, you already said you haven't. Alan?
No, what I mean, so not necessarily a build, but kind of those like milestone kind of releases, like where the teams go work for 3 weeks or 4 weeks and put the stuff together, then kind of kick over a version to QA. I've definitely worked in that environment with like kind of. That's what I meant. But we did have nightly builds in that place, and that was just more to kind of keep your stuff kind of fresh and integrate with those changes. But like we never really tested things all together until these bigger milestones. That's because so much stuff was changing, and it was too hard to try and adapt to those changes. And things that you were even testing and working on sometimes, like in my case, was like backup and restores. So they could even take hours to test, for real. So most of our work was done, kind of trying to figure out how to make shorter feedback cycles so we can kind of do our testing and mocking.
So maybe we
should. And then you throw it all together and give it to QA, once a month or whatever, and then they, shoot holes in you.
So maybe we should rephrase this then. Maybe he's not necessarily referring to the weekly build as in like, hey, let's compile this thing. Maybe he's really meaning like the weekly delivery.
I think it could be both, right? It could definitely, yeah. I mean, because it could be that your code didn't integrate well with my code or whatever, but then it could also be, does this thing work? Right. So I think both are legitimate problems that occur with this.
Yeah. I mean, he says that this is eventually going to lead into a crisis though, because going back to the schedule, the build schedule lengthening over time, where if it creeps from Friday back to Thursday, or, as Joe said, from, an entire week to, 2 entire weeks to do that, you're going to get into a crisis.
Yeah. My example, we were definitely building every night, and that was a pain in the butt, but at least it did mean that we didn't have to have some big integration day where we just kind of, fixed all the build servers. So I think, I can't really think of a good example where someone would be working in their own silo for a week or 2 weeks and then trying to all merge on the same day. That seems pretty crazy to me, but maybe that's old school, or maybe that's just a type of product that I've never worked on.
Yeah, I'm definitely way more familiar with nightlies, being the norm.
Yeah, you ever do something like you check something in at like 5 p.m. and it like works great, and somebody manages to get something else in, or somebody checks something in at like 4:59 that breaks you and you didn't even know it, and the build server owner finally gets to it like 11 o'clock at night, and pulls that andon cord and stops the train, and you're in trouble.
Yep. So then that brings us into the second one, which is
removing dependency cycles. And so our first approach was basically just having a kind of a weekly build that brought everything together. Now, the removing the dependency cycles is kind of taking a different approach. It's saying, hey, let's not have dependencies on each other's code. And so the developers will work on independent releasable components. And did we talk about what components were? Did we define the components?
That's kind of loose. I mean, you want to give it a stab?
Yeah, I think we talked about it last time. I just couldn't remember we brought it up last night. But it's basically the smallest releasable component. So there you go, recursive definition.
Let's call it the unit of work. Smallest releasable unit of work.
There we go.
Deliverable.
All right. Yeah, so we have I don't want to say microservices because that's an example of having smaller releasable components. But the idea of just breaking something into smaller releasable chunks so that, say Outlaw can work on the server, Alan owns the database, I've got the UI. And then each one of those is independently releasable and can actually, potentially work with older versions of its dependencies in order to kind of keep things moving and working.
Well, heck, even if we took it into the level of, let's say, JavaScript, like NPM, that would be a component, right? Or could be a very small component. It could be a massive component.
Well, you could have multiple components that are delivered by NPM.
Same thing with NuGet and C#. In Java, you could have jars and various different things. So, yeah, I mean, it could be anything that you're going to release out to another group to use.
Okay.
Yeah, and what this allows for, though, is it allows you to have more integrations more often, but they're smaller. And because of that, they're more manageable. So
yeah, and also,
well, I was going to say, I think one of the examples we talked about last time for components was one of you guys wrote some amazing logging component. I think it might have been Alan. So Alan releases his new, the latest version of his logging component, and now I want to use it, and maybe there's some change to it, or maybe there's just a new feature that I want to use. So when I bring in that latest version, I don't have to bring it in until I'm ready to do that integration and take advantage of that feature or make whatever the necessary change is for it. So it allows you to schedule those a little bit easier.
Yeah, and this gets back into what we talked about in the last episode with the semantic versioning. So when you complete these components, you actually version them so that other teams know you're communicating to them, hey, this one is backwards compatible. We talked about the second digit being, additional features being added or whatever, the third digit being bug fixes, that kind of thing. So you can actually communicate through your release number of whatever component you're creating so that these teams know whether or not, hey, we need to pull this in because it's fixing a bug or I'm getting new features or whatever.
And that was the reuse/release equivalence principle, or the REP. Episode 71.
Yep. And here's the thing, right? The whole purpose of this thing is when teams are depending on just components that are being released from other teams, then you don't have this whole need to do this weekly build to throw things together because they're all independently being tested,
Well, you hope.
It should be, right? Otherwise, everybody's going to get a pretty bad setup. But that's the whole goal is these things are being created. I hate to say it this way, but sort of in a silo. So they're more hardened. And so when they get released out to the other teams, then they just get plugged in, right? It's just a piece that gets added to it.
Okay, so how about this? Let's pretend I have a big project and it's only one project. It's only one component. So it's one big releasable monolithic application. And I still have a lot of different people on it. So now people might be working on, say, different namespaces or different files. And then it's really easy to have cross dependencies and not even realize that namespace A depends on namespace B and namespace B depends on namespace A, because that's not a compiler problem. That will compile just fine, I think. But well, we should try that. But it's much easier to make those kind of mistakes. And so I think this is also kind of a good argument for kind of having those nicely, kind of cleanly defined components, which we talked about last episode as well.
Yeah, I mean, problems like this are interesting. I've talked about it with several people that I work with, including Mike, is like, what you were talking about is you have one huge project that has a ton of things in it, right? And like you said, those things all sort of work together. And we'll get further into this a little bit later in this chapter here. But I think the answer is you start pulling those things out, right? The things that should work independently, that shouldn't be a part of this whole dependency thing, right? Like we've even talked about in the past, right? Don't make an object rely on an interface that has so much that it doesn't need, right? It should be the bare minimum of what it needs. So you start pulling those things out into their own components, and so that they can be broken out. And now you have these things that are sitting by themselves, right? That you could potentially version and do all those things too. I think that's probably the way to go with things like this.
Yeah, and last time we talked about the common closure principle and the common reuse principle as ways to kind of know like just when to break things up, and so it's not too small and annoying, and it's not too big and annoying. But if I just wish there was a way that we could statically look at our project and maybe do a little math and come up with a number that tells us whether we've got too much stuff that's too interrelated or too big, too concrete, or too abstract.
If only there was a way.
If only.
Hey, by the way, you mentioned the project, the namespace depending on namespace, depending on, namespace A, depending on namespace B, depending on namespace A, right? But if they're all in the same project, the namespaces are just an organization tool. So it shouldn't be a compilation.
Yeah, that's my understanding. So I wasn't sure if that was actually a problem or not. I know NDepend will yell at me when I do that.
Yeah.
So I guess there's the answer. Like you can do that and you shouldn't do that. And static analysis will catch it for you.
Because it's basically a folder, more or less, right?
Yeah.
Yeah.
And it doesn't even have to be in C#. You can kind of name those things whatever you want.
Yep.
Yeah. But even Visual Studio will yell at you about that, I believe.
ReSharper will.
Yeah. So if only there was a way, right? And this is where we talk about this whole, we need to remove the cycles. And so the graph that we were talking about where you have arrows pointing for your dependencies, your top level dependency pointing to your next level dependency, that's called a directed acyclic graph. And the whole goal is with those arrows pointing down from one thing depending on the other to another, that should never circle back up to any level up above it that could come back to it somehow, right? And that's what they talk about. You need to make sure there are no cycles. So that's what you're doing when you're removing these cycles.
Yeah, I will say, though, that every time I kept looking at that, I kept reading it wrong and be like, oh, well, this depends on that. Oh, wait, I got the arrow wrong.
Yeah, I have a hard time with those arrows. It's really kind of silly. I do like how independent graphs, I'll talk about independent a lot because it's like the only static analysis tool I've got experience with. But it's kind of silly, but it actually, the way it kind of draws the thickness and draws the arrows, it kind of makes them a little curvy. There's something about that curve that kind of like makes me understand it a little bit better. There's something about those straight lines and seeing them that just like it makes it hard to tell which direction it's moving.
I think there was another one that was mentioned previously. Was it
Sonar
Cube? Yeah.
Yep.
So that's another one of the static analysis tools out there that people use quite a bit. Anyways, so one of the questions we have is this advocating for breaking the teams by source code or by feature?
Yeah, this is going back to that other point about where it's like not only how do you organize your application, your software, how do you organize your developers?
This one's so hard. I mean, I think it depends on projects, and I get frustrated by this one because I don't really know a right answer. So let's take, for instance, let's say a website, right? A website, a lot of times the UI is like this one thing, right? And while it may all somewhat tie together, it's not like in most cases, and not most cases I've seen, it's not like you bundle up pieces of your website, right? Like you don't have this page has these components over here, and then you version that page, or you version those pieces on that page. And then you have this page over here that has other ones, and you version those pieces on the page. And then you've got things like routing, right? That is cross-cutting across the entire app. And this is where I have a hard time, like for whatever reason, when I'm thinking about middle tier code, like server side or even database code, it's easy for me to compartmentalize those things. But when it comes to UI pieces, this is where I struggle with how that happens. And what's the answer? Do you break it apart to where you have multiple teams that work on one page?
I don't know about
it seems like the book kind of assumes that you're broken up almost by component. So that people working in component A don't know about what's going on in component B. And like that's kind of the point of the abstraction there. So I kind of feel like there's some bias for that there.
But what about like a website with like routing though?
Well, another way to say that component would be feature, right? So going back to, you could break it up by feature.
If
a component is a feature. Logging is a feature. If going back to the logging as the example,
right? And that one's easy for me, right? Like I said, when it comes to UI pieces, this is where I get really frustrated when trying to figure out how to split those things properly, because you have things.
Well, even in your web example, though, you could have components within that web example, and each of those web components would be responsible for their own routing. Going back to your routing question, right?
But you have these pages that hold these components, right? So you have a page and it has 5 components on the page. So those components are completely independent of the routes, at least from a high level view of that page. You know what I'm saying? And that's where it's hard, because routing's like its own beast. Like that's a page by page thing. You can pull in as many components as you want. If you wanted 20 components on that page, you can bring them in. And all those components have state that is typically pulled in by whatever the URL is. And so now how do you break that thing up? Does somebody own routing for the entire website and that's the component? But that component has to be aware of all the other components on the page, because it's what hydrates those things.
I don't think you could do that. I don't think that would be.
And that's the part where, like, talking about certain parts of applications, this stuff really makes sense to me. But other parts of it, like that, where there's things that literally are so intertwined with the other pieces that really drive me crazy. Like, because
if they're intertwined, then they should be deployed together, right? And, ideally using the common enclosure principle, or according, if we were in a perfect world, then things that change together would stay together. So if the routing is entwined with the website, then the website would be its own component.
So we're saying the website, it's just one component. You don't break it up
if it's entwined. Pieces. So either you need to figure out how to break it apart with some sort of like modular interface, somehow, and have those be separately releasable components, or you just, have it be one big fat component.
That's such a hard.
You can still have modules. You have just like you have namespaces in a DLL or something. It just, if that stuff is really so entwined that every time you're changing a route, you're changing the website too. Then why separate them?
Interesting.
I was trying to think of an example, like we've talked about Atlassian before. So like Jira would be one component. Confluence would be another component.
Yep.
Right.
But
like
even
those
then,
are like whole apps, though, right? Like, and that's where I feel like components stretching it. Like that's not a component. Like a component.
What about this one? What about Office 365 on the web?
Mm-hmm.
Right. And within Office 365, there's Outlook, there's Word, and there's Excel. Those could be different dev teams.
Those are apps, though. I'd say even within those teams, right? There's going to be components.
But there's still the container around that.
Right.
There's the Office 365 container around it.
Right.
Right?
Yeah, I think this is where it's hard to draw the line between a component and a full-featured app, right? Because that's where I wouldn't be surprised. Like, for instance, Office 365 is a great example, or even Atlassian. They're going to have a logon component that all of them use, right? Like all of these things are going to have some sort of token that says, I have access to products A, B, C, and D. So that is a component. That whole authorization, authentication piece is a component that they all share. And then there might even be additional things. Like a perfect example now is cloud storage, right? If you want to save an Excel file online, you can say, hey, save it to my OneDrive or save it to whatever. And that's a component that they all share. But then when you start looking at something like Excel, there's tons of different components within it, or even Word. And that's where I'm like, how do you break that apart?
I mean, even if we were to like talk about another even if we were to break this out into another application, like a Spotify, for example, there might be one component that's just the ads that are going to be served, right? And deciding what ads to show you. There might be another component that would be search, right?
But those aren't components, right? Because those are, unless they're an actual separate like service, like you would deploy the search service or the ad service, and all of that is kind of transparent to the user because they're just going through their app, which I would consider that another component. So the whole app, I would say, is one component.
Well, I was thinking of the app as comprising of multiple components within it,
a container of components.
It's a container of components.
But you can't deploy You can't deploy one of those individually. You deploy an app version.
The app version could be deployed. The app version is an aggregate of some selection of components. But what version of those components you decided to include in that version, you could change. Now, once you've made that installer and it's out there, you're done but even in an update capability where your application can update itself, you might update selective components.
Well, I like the Spotify example because I think there are a ton of features in Spotify that you can absolutely identify as separate components. Search would be one that could totally be a service. Totally.
But you can't deploy just the search.
It could be like its own DLL. Why can't it be its
own DLL? But you still, I would say that
component.
So the DLL maybe is its own component, but when you're talking about the app, I would say the whole app is a component.
No, and that's I think where we've got to sort of draw this line or differentiate what an app and a component is. So what you're talking about is you can't deploy that UI without the search in it, right? That's what you're talking about. That's an application. That's a compilation of all the UI pieces that tie all those components together, right? So that search box that's in that UI is using a search component that has probably been built that allows them to be able to search whatever their databases are. I'll give you another one, like the share, like play on my device or play on my receiver or play on my iPad or play on whatever. That's probably another component that they've built that works on their mobile app, on their web player, on whatever else is there. And so I think those are the components. You're talking about the entire application. You're correct. That app can't be deployed without those components, but I wouldn't call the application a component. I don't think, because it's not used as a component. It's an end user.
It's an aggregate.
Yeah.
Which is, so now circling back to your web example, that web app is an aggregate.
It is. And that's what's hard. Like, how do you, so like I said, I can see how you can break down components, like functional pieces. I get when you start talking about UI pieces and how all those things tie together. And I'm not as familiar with Windows programming or desktop type programming applications, but I'm sure the same type problems exist there, right? Where you have to share state between various different places. That's where it feels like it's a lot harder to break things out so that the problem that we mentioned earlier, where you don't have too many people working on code that's going to step on each other's toes, that's the part that frustrates me, because I can't figure out, or I haven't at least thought of a good way to where you can split that up and say, okay, you own this piece over here, and somehow it's just going to work with this piece over here. You know,
honestly, I mean, you mentioned managing state, and I don't know why in reading this chapter, but for some reason I had this thought that came up, which was that, managing state, it's got to be like the hardest thing that we do in our job, second to deciding what to name something. Like that's up there. That's way number one. And then managing the state is like, it's a distant second, but it is second.
Yeah. Yeah. State's difficult. I'd say caching also. I mean, we've talked about it, like all those type things where you're having to either rehydrate a portion of an application or save that portion of the application so it can be brought up like that stuff is so freaking hard.
Well, caching is a form of state management, right?
So it is. Yeah. Just a speedier one. So yeah, anyways, I mean, I didn't want to go on that too long, but it is one of those things to where some of this stuff isn't just cut and dry, right? Like what we're talking about right now, it's easy to compartmentalize some of this stuff, and other pieces of it are just really hard. They're really hard to break down in any kind of, not meaningful way, but in a way to where you're actually making teams to where they can work efficiently together.
So coming back then to the dependency cycles, we know that having these cycles make the code, well, for one, we're not sure how we could actually have these and the code compile, right. But assuming that we do, and we're working in a compiled language, then it would make it, the release is difficult and fragile and, likely lead to the morning after syndrome. So how do we break the cycle?
Yeah, one way is a dependency inversion principle. So basically using strong interfaces for the different components and kind of having those contracts or act as a buffer between the components. So you're not depending on component A from component B. Now you're depending on interface A, which component A just happens to implement. And so you got a little bit of buffer there.
Yeah, I really like this because in one of them they talk about, you've got this strong dependency from A to B, like you said, right? And how do you break that? So the interface that he was talking about is you might create a project that's nothing more than an interface, right? And let's call that interface project. So now A is going to depend on interface project and B depends on interface project. So now there's no longer a line from A to B. They're both pointing to that interface project.
So am I alone here then that in this portion, it seemed like it was understood that dependency injection is used?
That's pretty much it. Yeah.
Because he never described, using dependency inversion to invert the direction of the dependency with the interface, but he never described, okay, well, how does the thing that needs to use the interface, how does it ultimately, like what method or class, like how is it getting the actual instance of that other object? And the only way that I could come up with was dependency injection.
I'd say that's probably the most common. I don't know if you could...
But you can manually, you basically have some sort of main method or some sort of bindings defined somewhere. You have some sort of factory somewhere that kind of somewhat crappily encapsulates that dependency.
Okay, so you have
somewhere along the line there has to be
but in a separate project or in a separate, yes, it would be a separate thing that would bring those together, right?
That's what I'm saying. That was never part of his diagram.
Yeah, yeah. You could do it. The dependency injection thing would be a nice configurable way to do it. Whereas if you went the factory pattern or something like that, you'd probably have to put that in a new project that they both depend on, right? And then that way you could create those things.
But you see where I'm going with this, though, because he took the time to draw out a new project that contained only the interface, but not the other project that you're suggesting that would have the factory that would include all of that then you don't need the dependency on that project that contained just the interface. You actually only need the dependency on the project that would create I guess you would need no, because the interface project would come along for the ride, right?
Yeah.
So, it was still weird. So I'm pretty sure he was assuming dependency injection.
Yeah, it's kind of an interesting omission. And so, one simple example here could be like if I've got code that currently depends on a database project, I could instead swap that out with, say, like an interface for data provider, some sort of data provider module. And it just so happens that you only have the database, but you've severed that official line. So now you only have to worry about updating your, say, server code when the interface changes. And everything that happens behind that interface is guaranteed to or it's supposed to just work. You shouldn't have to be aware of anything.
Yeah, so
doing this...
Oh, sorry.
I was going to say doing this enables us to know how to build the application because we understand the dependencies, and it just draws some, clean little boxes around our stuff.
Yeah, we know the order of what things need to be built first. There was, this was kind of funny. And maybe I was just a little dumb when I read this part. So he was talking about how, when you have the cycles, unit testing and releasing are difficult. It's just difficult to isolate the components, and that the build issues grow geometrically with the number of modules, right? Now, here's the question. where maybe I'm showing my own ignorance. Had you ever heard of geometric growth before that statement?
I picture a polygon growing
outward. Yeah, I don't really know what that means.
I think you meant logarithmic.
So I've heard of things
linear.
in regards to linear, logarithmic, exponential. I had never heard of geometric growth. So I had to search for it because I'm like, what is geometric growth? And so I came up with this one definition I liked. That was geometric growth rate is applicable to compound growth over discrete periods, such as a payment and reinvestment of interest or dividends. So it's building back on itself.
Yeah.
That's geometric growth.
Yeah. The definition from OECD, never heard of it. It's a constant ratio. So yeah,
that's the one. Scroll down to the middle paragraph.
I didn't actually go to the page. I was looking at the Google
but that was the one that I liked though. And I like the example of the payment and reinvestment of interest. Is like, okay, I get where he's going. I understand now where he's talking about like the compound. As you add in the next component, right? It's compounding on itself, making it. But yeah, that was a weird. I'd never heard of that term before. All right, sorry. Moving on.
Coolness. All right.
That's pretty specific.
What's the next piece? All right. So the next one that we talk about here is top-down design. And basically, the whole purpose of this section is to say that you can't design something perfectly from the beginning because there's no way for you to see this code and see these dependencies from the very get-go. The whole purpose of building software is, the way he calls it, is the component structures jitters as they grow, right? Which kind of makes sense, right? Like as you get in there, you're like, oh, wait a second, that changed a little bit, or this requirement's not what we thought it was. And so these things are shifting around on you. So to try and spend just a crazy amount of time up front trying to get the perfect architecture and perfect design to get those acyclic dependency graphs set up properly is not the way to do it, right?
Yeah, he describes it really well in this section where he was saying that this diagram, the component dependency diagram, this is a map to the buildability and maintainability of the application. And so you can't build the map. You can't create a map of the buildability of it until you have something that you can build. And then once you have something that you can build and you can build that map, then you can decide, oh, I don't like the map. I need to make these adjustments, to get rid of cycles and things like that.
I think that's so important though. Like what you said with the buildability and the maintainability of the application. All of this that we're talking about in this chapter has nothing to do with the quality of code. It has nothing to do with, did you do your classes the proper way? It's all about how do you grow the application in a way that's not going to drive you crazy or introduce just tons of build problems. This is all about how do you make it to where this thing can grow and still be maintained over time in a component way, not at the low level class code way, at the component way. Now, we'll talk about code ways to make that possible, but it is interesting that is the call out.
Yeah, the most common theme of any software craftsmanship book that you'll ever read is going to be that you got to just iterate.
Yep. Don't ever think that you can do it all in one shot.
Yeah, when we say it talks about the buildability and not the functionality, it's like you kind of, if you think about that simple example we gave, a website that has like a UI, a server, and a database, and maybe we'll say a logging framework. Someone says, okay, so how do return refunds work? And you're like, you start with the UI and the server and the database, and there's a lot of logging mixed in there. It's like, okay, so what the heck? It just doesn't really make sense for that. So this was just about the buildability.
Right.
Oh, so what parts of the application then are the most volatile?
That one's
And
interesting.
we haven't really talked about volatile, but it basically just means what changes the most. And so as far as buildability, I've always heard that the UI is like the most expensive code because it's rewritten so often. I don't know if that's actually true or not. The book mentions the database being particularly volatile because changes happen a lot to it. Well, pretty much anytime you're adding any sort of new concept or anything, you're adding columns or tables or whatever.
Yeah, I would probably. We have business rules here with a question mark. I'd say that's probably, once you lock those things down, those probably don't change a ton, at least for your main use cases, right? I would say the UI is probably the one that feels like, because it's the most affected by whims or new designs, or, hey, we want to try this. We want to split test something. We want to do whatever, right? Like, it's the thing that people, that they interact with. And so it's the one that people want to tweak the most.
Well, I do feel like business rules kind of change just because we never get them right. Like, if we ever got them right, it would probably be different. But you can give an example. It's like we say no returns after 30 days. Unless a customer service agent says so. Oh, but now, so there's one change and say, well, that customer service person is happening too often. Now we need accounting approval. So, we do that. And so now accounting is getting too much. So now accounting needs to only approve things more than $500. It's like, okay, this is obviously changing a lot. And that's, just one very small example. But I do think that there is some flex in business rules there, even if it's just minor, like changing, from 4 to a 5 or whatever.
Yeah.
Yeah, I agree that you're probably going to see the most change on the UI because that's where your customers are going to be. So you're going to want to keep the attraction high. You don't want it to be stale. So you're going to want to keep that up. But one that you guys maybe haven't considered is, what about non-functionals? Right? Like changes to what you're logging or how you're logging, or well, we got to make this change because we want this to process faster, or we want to split up the architecture so that we can deploy independently. Oh God, we went too far to microservices. It's time to bring that back.
Nobody ever said that.
That's a good point.
Yeah, I agree.
Yeah, so after reading this book, I did a little kind of holiday project where I did a game. And the first thing I tried to do was like, okay, I'm going to think like an architect. Let me draw some boxes. And I started trying to kind of draw stuff. But what I ran into really quickly is like, I don't know what I'm doing. I don't know, I don't know what kind of game I'm making. I'm making a bunch of assumptions. So it didn't really make much sense for me to draw anything. Plus, I was doing just what the book says is not a good idea, where I was like drawing components like, here's my graphics layer and here's my data storage, whatever, that I'm trying to figure out like how the gameplay works from that. And it just wasn't happening. You
were trying to draw the map before you had anything to build.
Yeah. And I wasn't even drawing the right things, Like, let me draw a map. Okay. Here's some blue, red.
Have a little green over here.
Yeah.
All right. Start navigation.
No, it's working. Yeah. Right code.
Yeah. Good enough.
So one thing I thought was cool is like, we talked about this component diagram and dependencies and the buildability. Who makes that diagram? When do they make it?
According to Uncle Bob, it would be the architects.
Architects, is that like a Monday morning, like we all draw our component diagram? Well, when does this happen?
This is I don't know if you're baiting me, but I'm going to take it. So he says that this is a quote from the book. The component dependency graph is created and molded by architects to protect stable, high-value components from volatile components.
Okay, so maybe this is the kind of case where someone would say, you know what? The developers are going a little crazy. They're complaining that the code is hard to work with. Let's draw our components up here and see if we can figure out where some of our trouble spots might be and what to do about it.
Yeah, probably. And I'd venture to say that you'd probably use tools like, the Visual Studio Analysis thing to show you where your dependencies are, or Independ, or, any number of other things to assist with that, right? And I feel like we're going to talk a little bit about how we can quantify some of this stuff here in just a little bit.
But maybe going back to part of Joe's question, though, about like, well, is that a Monday morning thing or whatever? maybe some static analysis tools in your build pipeline.
Totally. Because
Right?
they could even spit out the reports, and you could have thresholds set up to alert you of some of these things, right?
Or if nothing else, just to keep it up to date so that, when you do want to see it, at a minimum, at least it's already there, right?
Yep. A release is taking longer than anticipated. Why is that? Let me go look at our dependency graph and see what's going on.
Yeah, and that's a good way to kind of get this kind of conversation started. Like if you're working with somewhere and you're feeling some of the pain about the code and management's tired of hearing you complain about the code and they're not really taking it seriously, maybe you can say, you know what, let's throw some static analysis on here so we could just kind of graph things and see that, just make sure that we're going in the right direction. That's something measurable. That's something management would normally like, and you can do it really cheaply sometimes, maybe even free.
Man,
so it's something to consider to get that conversation going.
It's been a long time since we've talked about static analysis. I think it's worth saying the whole reason it's called static analysis is because it's analyzing the code after it's built, or it's analyzing the state of the code. It's not analyzing it running. It's not any of that. It's just looking at dependencies and how things are connected and all that kind of stuff. So it's worth knowing that when we talk about static analysis tools, it's literally just looking at how your code is set up and connecting the dots between everything.
And I've never seen a static analysis tool that will call out individuals. So you don't have to worry about campaigning for getting the static analysis into the pipeline and then having the first report come back like Joe's code stinks the most.
Well, that's why I like to make all my namespaces like that. Joe's code.
Yeah. That's right. All right. So let's take a little break and talk about how much we love reviews. And we actually set up a URL. So you can go to codingblocks.net/review. And we have links there to iTunes, Stitcher, Podchaser, anywhere else that you might be able to leave a review. And we know that, iTunes is a pain in the butt if you don't run it. But a lot of times you can even do that stuff in the apps there. So we love that stuff. The reviews are really huge for us finding new listeners and kind of surviving and competing with other podcasts. So we love those reviews. We get fantastic ones. We love reading them. And so if you've got a few minutes, please hook us up.
And with that, we head into my favorite portion. Survey says. All right. So last episode, we asked how many developers are at your company? And your choices are just me, about 5, like Captain Planet, or closer to the 20 mark, headphones are required, or 100, crazy, right? Or 1,000 plus, enterprise. All right, let's go with Joe first.
I'm going to say about 5.
About
with
5, okay.
30%.
5 at 30%.
Yeah, I know anecdotally, we don't hear a lot from people working at really large companies. Like you would think, Microsoft has 80 bazillion developers that, just based on those numbers alone, you'd see a lot of activity from those. But I think a lot of those bigger companies kind of have a closed ecosystem. So there's not a lot of kind of people necessarily speaking out or kind of living out in the greater dev world if they work at one of these large companies. So I'm gonna go small.
Yeah, I'm kind of thinking along the same lines, just because I feel like a lot of people that hunt out podcasts or learning things are because they're not immersed as much in it, and they thirst for it. And so I'm thinking smaller as well. I don't want to pick the same one you did, so I'm going to say closer to 20. And I'll go with, I'll say 30% on that one also.
Okay. Survey says.
We're both wrong.
No, Joe nailed it.
Awesome.
It was about 30%.
Really?
Was the top choice.
30% on the money?
Yep, he hit it on the money.
Cheater.
What do I win?
Yeah. So that was very interesting. And I guess it kind of makes sense, though, because most businesses out there aren't dev shops, right? So, it might make sense that most, companies that might want devs wouldn't, just from a numbers game, right? There would be more that wouldn't have a large team.
What was the second one?
You had the second.
Okay.
Yeah.
So it is a bunch of smaller shops.
20, but it was 20%.
Okay.
Yeah.
So that was 50% of the
fell
overall
off
makeup.
after that. Yeah.
What was the next one? 5?
Well, Crazy or the
Pardon
100 and Enterprise were both at around 19%.
Well, that's kind of cool. That means
So-
that there are people that are working in larger companies that are still trying to improve their craft. I love that. That's awesome.
Yeah.
Yeah, we know some of them from the Slack group, but it definitely seems like the vast majority are smaller shops.
Yep. Excellent. Oh, yeah, we should.
All right.
We should what,
forgot to
Alan?
mention.
We always forget about this until after the fact. So we're talking about clean architecture and we love to give things away. So be one of the people that leaves a comment on this episode with some of your thoughts about what we're talking about here. And, you'll be entered for a chance to win a copy of Clean Architecture by Robert C. Martin.
And if you're looking for an idea as to what you might write about on the comment, let me give you an idea. So today's survey, we're going to ask, how often do you shut down your computer? And this was sent in from the Slack channel, and I forgot the names.
It's either Swix or Dance to Die.
Yes.
But I don't know which one.
I think it was both. It was a combination of the two in a conversation.
New York City represent.
Yep. How often do you shut down your computer? And your choices are shut down daily,
Nobody does that.
every week, every month, or only when the updates force me to. Or who shuts down their computer? Or I don't shut down often, but when I do, it's because it blue screened or kernel panicked.
What about adding another one because I'm a pain in the butt for vacations only?
Sure.
Okay, so PTO.
Maybe one for weekends.
Oh, it doesn't have to be it doesn't have to be paid. It could just be time off.
Just TO.
TO. That's right.
Vacay.
There it is.
There you go.
Yeah, I shut down daily. I don't mind saying it.
Ain't nobody do that. That's crazy.
Yeah, no. One third of this podcast does.
I do vacations. It's like symbolic. I'm like, oh yeah, this is gonna feel so good. Power up. You see like one more email come in. You're like, too late.
Didn't see it.
Yeah. And what really happens though is like Windows is waiting for the following applications to close, and it shows you a blank list, and you're like, well, damn it.
Oh man, that's amazing.
True story.
Alan, you're not going to comment? You just never shut down?
Man, I bet I shut down every weekish somewhere.
I'm curious to see like so going back to the comment portion of this episode, if you're looking for an idea, you could write in your uptime. Let's see.
That'd be awesome.
What kind of crazy uptimes we get. If people have commas in their uptime, then I guess they're doing it right.
Yeah, no doubt. But they're also not on Windows or Macs.
Or they're doing it wrong because they're not up to date with security patches. I don't care what platform you're on. Eventually, if you're going to install some patch, it's going to require an update. So,
yeah, I agree.
Shut down and
in
restart.
fairness, we shouldn't be talking about your Linux server that you've got shuffled away in your closet that you haven't seen in 3 years. This isn't. We're talking about things.
We're not talking about
use.
appliances,
right? Things that you use.
Yeah.
And now we're moving on to the stable dependency principle. So we've been talking a little bit about volatility and stability, and we wanted to point out that neither one of those is like particularly a good or a bad thing. Like change is good. Not changing things is also pretty good sometimes. And volatility is necessary and expected. Now, ideally, components that we expect to change should not be dependent on by a component that is difficult to change. And when I say something is difficult to change, one way to measure that would be based on how many things are dependent upon it. Does that make sense?
I think so. So going back to our website example, right? We want the UI to be volatile. We want the database to be stable. So we're okay with the middle tier depending on that database in terms of the stability and the volatility, but we don't want the other direction. We wouldn't want our database to be dependent on the UI, since the UI is expected to change.
Right.
Not sure how we could actually make that happen, but it would be weird if we could.
Yeah, we want that UI to be as easy to change as possible. And the easiest way or one easy way to do that is to put dependencies on it. So it'd be kind of silly if you had some sort of bot or service that actually interacted with the website to do something. Like you could imagine like some sort of integration test or something that actually went out to the website, used the login form, logged in, placed an order, whatever, to do some sort of testing or something. That's something that's really common with a tool like Selenium or something else to do some sort of like integration or web testing. But those tests are notoriously fragile because they're depending on code that changes really often. And that's a bit of a problem. Luckily, I don't know of too many other examples where something like interacts with a UI in order to interact with the program that you control. Something that would normally go through the server or maybe even to the database directly. And so that's kind of an example of us not going through the most volatile code because it just doesn't really make sense. And it's a lot harder.
So I think the takeaway here is to not test our UI.
Right.
That's what I got out of that.
That's right. So components are that are dependent on more often are harder to change. And that's because we say they are more stable. And we do have some tools to kind of look at our components. We talked about like static analysis to figure out which of our components are more stable. And I kind of have a hard time saying the word stable and meaning just that it has more dependencies on it. But that's literally the definition we're going with in this chapter.
And the reason they call it that is because what makes it stable is the fact that because it does have so many dependencies on it, it's really hard to change because you'd have to go touch all those things that depend on it to ensure that they all still work properly, right? And so that's the only reason it's called stable. So if you, like, for anybody listening, if that should help you. The more stable it is, the more stuff is depending on it. So the bigger pain in the butt it is to actually change that component because it's going to trickle all the way up.
And stable doesn't mean good here.
No,
sometimes we'll say like a stable release. It generally means it's good. Not in this case. We're literally just talking about how many things depend on it.
Yeah, it's neither good nor bad. Neither good nor bad. It's literally just hard to change.
He does break apart these though a little bit further on, where he says that if it's so instead of describing stable as it's dependent on by a lot of things, he calls it responsible.
Right.
So if other things are dependent on that component, then that component is responsible. And if that component doesn't depend on anything, then it's independent. And then flip side, the inverse of that is that if your component is dependent on a bunch of other things, then it is irresponsible. And if it's what was the? Yeah, and if it is, and if it can change because of those dependencies, then it's dependent.
Yeah, and so ideally, components that rely on many other components, those are the ones that you that kind of by their nature are more volatile. Meaning, it's easier to change because there's no downstream side effects that you're responsible for.
Yep.
So UIs are irresponsible. Not UI developers, just the UI.
Yeah, and that makes sense. Like that they would be volatile, right? Because it's ultimately there's this indirect dependency to the database. And I say indirect because it's going through some middle tier, and so that database is a stable component, right? And we've decided that the UI on top of that is volatile. You expect that's going to change, so that makes sense that it would be like that. Yeah, I don't think I made my point.
No, it does. You did. It makes sense that that's going to be exactly that. The volatile one's the one you can change all the time. Don't have to worry about it. Nothing's attached to it. The database being the one that's transitively attached to, you can't just change it willy-nilly because you're going to break the middle tier and you're going to break the UI. Right.
And so we can actually measure and give ourselves a number for any component stability by counting the number of dependencies that are dependent on it and how many we are dependent on. And in the formula they give in the book, it's basically just a simple ratio. But they say the fan out, which is the dependencies that we're dependent on, is divided by how many dependencies we have plus the dependencies we have out. And we end up getting a ratio between 0 and 1 that represents the instability. So if I say you've got an instability of 0.1, that means...
Well, 0 would be maximum stable, and 1 would indicate maximum unstable.
So maximum stable means that you don't depend on anything else, but everything depends on you, right? That's maximum stable.
Right. You have things depending on you.
But you depend on nothing else. So the database would be a perfect example of where if that was your very most ending state, that would be your stable one.
Or we could take this into another context and talk about like from an OS, like the kernel.
Yeah. Okay.
Okay, so the kernel has an I or an instability of 0 because it's very stable because it's got a ton of dependencies on it and it doesn't depend on anything.
Correct.
Whereas the opposite would be like, say, I guess like a UI that has lots of dependencies on other things, but nothing depends on it. So it would be closer to a 1 in this ratio.
Completely unstable or unstable. We call it
unstable.
Yep. And then if you're talking about the processes that hook into the kernel, that's sitting somewhere in the middle, right? Because your UI is going to use these processes that then use the kernel. Now you're probably falling somewhere in the middle, right? Like you're maybe at a 0.5 or something, who knows? But you are you're somewhere in the middle of instability there because you have incoming and outgoing dependencies.
So if we were to run this formula on each of the components on our simple website example, I would expect that website to be a 1, just like we said, because it has nothing depending on it and it depends on lots of other stuff. The middle tier now is a little bit different. It has something depending on it, the UI, and it depends on the database. So I'm going to say that's going to be, roughly, it's going to be 0.5, right? Because it's
if we're doing one in,
out
one out
over...
Yeah.
The in plus the out. So 1/2. So it's right in the middle.
Now I do want to back up here for a second and say from a more realistic, more architectural standpoint that we're talking about, typically we're going to be talking about things at a particular tier, right? So let's say that we're talking about the middle tier. You're going to have various components within that middle tier to where the dependencies are on each other, right? So we talked about logging. You have maybe an accounting thing. Maybe you have a customer service module.
Authentication,
all kinds
emailing,
of things.
Notifications.
This is where it all really comes in. We're grossly oversimplifying it just so that we can talk about 3 layers and make these numbers mean something. But when applied more at a particular application and all the modules within the application, that's where this stuff really becomes useful.
Yeah, and I'm going to want to see all those kind of guys. Like I want to, if I was going to do static analysis on the project, I'm going to want to see most of those guys somewhere in the middle, somewhere in the 0.5 range to some sort of standard deviation there, and something like a database that provides like a foundation and doesn't really depend on much else. That should be closer to the 0. So now, if you've got an email service or something, and it's showing as really close to a 1 or really close to a 0. Then that's something that you want to take a look at because that's something that's kind of fishy. It's in the middle of your stability, but it's either got a lot of stuff depending on it that probably shouldn't be, or it has nothing depending on it, which is, just throwaway code. And what's it doing?
The cool thing here, though, is that we've now learned a way that we can talk about the quality of our code in regards to math.
Mm-hmm.
Yes.
A quantifiable approach.
So there was an interesting way of expressing this that I wanted to just read, where he was talking about like if when it's I is equal to when the I metric is 0, when the instability metric is equal to 1. I'm sorry, I said 0 first, but I meant 1. When it's equal to 1, it's the lack of dependence gives the component no reason to not change. And the components that depend on it may give it ample reason to change. So this is kind of where I kind of got ahead of myself and lost my point before. But going back to that UI example, right? Because the UI isn't dependent on things like the database, or nothing's dependent on the UI, like the database isn't dependent on the UI, then there's no reason to not change the UI, right? If you want to change the logo, you want the logo to be on fire? Sure, make the logo on fire. You want to change the color? Sure, change the color. Like, there's no reason to not change it, right? It's easy. Nothing's depending on it, right? But now when the database tier changes the way maybe addresses are stored, right? Then the UI might have to reflect that change back out, right? So there's no reason for that that component to not, that UI component to not change, but yet because of its dependencies, it can have reason to change, right? And inverse that is, it says when it's equal to 0, its dependents make it hard to change the component, and it has no dependencies that force it to change, right? So nothing's forcing the database to change per se, unless we go back to like non-functionals. But let's ignore that. Nothing's going to force that database to change, but because of the things that are dependent on it, it's going to be really painful to make those changes. And when you do need to make those changes, it's a coordinated effort a lot of the times.
And I don't even think we have it in the notes here, but this is, or do we? Let's see. Okay, no, this is perfect. So we do have this, and it should sort. So your most unstable, we talked about the website, but let's go into what we had sort of talked about in component things, so that you have loggers and database and authentication and all that kind of stuff. When you look at your chain of dependencies, your higher instability ratings should be at the top, and it should go down to your lowest down at the bottom. Every time you go down one of those tiers and you look at those dependencies, anything that's below it should have a lower value. And that's one of the things that he says here, the SDP, so the stable dependencies principle. Thank you. It says that if the I metric of a component should be larger than the I metric of the components that it depends on. So as you're going down, that stability number, that instability number should go down.
Yeah, if you think about the Spotify example, where you can listen on the web, you can listen on iOS, you can listen on Android, you can listen on your watch, whatever. Each one of those is, we'll just call them component for now. Each one of those components is at the edge. This is the most volatile. So if you want to change the orientation of the watch, or you want to change the colors on the iOS version, you can go ahead and do that without affecting anything else. But if you change like the core database or the server logic, then you could potentially have to change all of those leaf nodes, right? So it's a way of kind of one thing that's nice about this is if you've got this organized well, then someone knows whenever they make a schema update that they can tack on a couple extra days to that estimate, because it's got a lot of downstream effects.
Mm-hmm.
Yep. Yeah,
like and if you don't believe me, just go rename one of your tables and see how much other code you have to touch.
Man, I actually had somebody ask me years ago, "Hey, if I change this column name, is that going to mess you up?" I was like,
"What?
Do you have to change your query?" Like, that was my question back. Like, you change that column name, what do you got to do? All right, now multiply that times 3 or 4. Like, seriously. Oh.
Yep.
It hurt my brain.
And we can kind of minimize some of those changes that are necessary by like having nice clean version numbers. And so iOS could depend on our server project 1.2, and Android could be like 1.1 or whatever. We can also use the dependency injection principle to create an abstract component that can kind of just act as an interface between components and keep things separated and act as a buffer.
Wait, you mean the dependency inversion principle? Did you?
Injection principle.
This is the one that
This is what I wrote.
Yeah,
I don't know
this
if
is
that's
the one
right or
that
not.
I had mentioned earlier, where this might be nothing more than a project full of interfaces. The project does nothing itself, but it gives you a way to change the dependency flow, right?
I'm assuming we're talking about the D from solid, right?
Yeah, it's inversion principle.
Okay.
I
Just
wrote it wrong.
Updating the show notes so that, yeah. All right.
Because we have awesome show notes. You should check them out.
We do.
We hope you check them out and you can comment on them.
Yes.
I even drew the
book.
triangle last time. So you should definitely go look at my pretty drawing. The ultra confusing triangle.
There needed to be a picture of that triangle. All right. So apparently we're not good at describing pictures on
Especially not triangles.
not triangles.
They're so hard.
There's too many sides. All
Did we
right.
get some feedback about that?
So many angles.
I think we had some people who were like, man, I was so confused.
Oh, dang.
Yeah, we were too. That's all right.
We're going to do it again here in a minute.
Yeah. All right. So the next one we have is the stable abstractions principle. And this one basically says that a component should be as abstract as it is stable. And so what does that even mean, right? So basically the gist of it is code and stable components are the hardest to change, so we shouldn't put logic that is likely to change in there. Stable abstraction principle states that a stable component should also abstract so the stability does not prevent it from being extended. Unstable components should be concrete since its instability allows concrete code within it to be changed. So basically what they're saying is create abstract classes or interfaces for your stable components. And then that way you can extend those things. You can, make other things do what they need to do. And those are sort of your contracts for it.
I was kind of curious about this section because he definitely, even in the pages leading up to this one and going forward from here, was referring to the abstract classes. And then I was like, well, I wonder why the template pattern isn't enough. Like it wasn't mentioned in any part of this, but I was like, well, couldn't that also help with that, adhering to the open close principle policy?
Well, that's sort of what an abstract class would give you, right? If we're talking about it, kind of does, because those are pluggable patterns that get overridden, right? And so
an abstract class, though, is one that you would have. There is no instance of it. You'd have to create a class that inherits from it.
Yeah. Yeah.
Right? I mean, obviously, to take advantage of the template pattern, you'd have to inherit as well. But it was just curious, though, to me that his answer to this was only about the abstract class and not like other ways that deal with the open close. Because we've seen this pattern where at the component level, a lot of these principles, there is a corresponding class level principle that goes along with it, right?
Yes.
And this was along the lines of staying close to the open close principle.
So I think totally, yeah, the template pattern would fit into this thing.
And for those not familiar with a template pattern, a template method pattern, like picture you have a class and you have certain methods in that class that you allow your users the ability to override. And then you have some other method that will call all of those methods in order. And so if one of those methods was overridden, it's going to end up calling your method. So, I'm trying to think like if you had a class, let's just say you had a method 1, method 2, method 3, and then you had a run method that calls method 1, method 2, method 3, and you allow your users to, or anyone who's developing on your class, they could provide an override to method 1 or method 2 and or method 3. And so when that run method gets called, it'll call the appropriate method
at the appropriate time.
Yes. So the template method pattern is just a neat little way of allowing your users, and users in this context would be the developers, but allowing your users the ability to inject their own functionality in certain places, maybe in its entirety, maybe they replace entirely whatever the previous functionality was, or maybe they only replace, a portion of it.
So this is kind of interesting because, I mean, the whole thing about an abstract class, like he doesn't dictate, at least not in this chapter, as far as I remember, and maybe it's further in the book, is they talk about the amount, and we'll get into some of the equation stuff here in a minute, but the amount of abstractness in it, right? So I don't know if he's saying that component that's being relied upon, just basically the nature of it is abstract, right? Like there's not a ton of implementation in it, or what is in it is fairly bare bones. And then if you want to use it, you're going to have another component outside of it that extends or implements that,
so maybe I read abstract as abstract class, and that's not what he meant. Yeah, that's possible.
And that's what I don't know. I mean, he doesn't necessarily spell it out completely, but it could be that, you have the abstract classes in there, but you also have implementations within that. And I don't know within the component. And that's kind of what I'm getting at because.
Yeah, no, you're probably right. That's probably a better interpretation of this portion.
But we talked about earlier too, like you sort of almost have to make the leap or the assumption that he's also assuming to a certain degree that you're doing dependency injection. And that could be part of this as well, right? Like it could be that you have this abstract component down here, and then there's all these other components out here that could just be injected in that extended that thing. So it's hard to say. There's a lot of interpretations we can make here, but at least keep that in mind.
So check this out, like our Spotify example, right? We've got, we'll say, 5 different, kind of clients or UIs, depending on a server project, depending on a database project. Now, the stability of that server project is really high because it's got 5 dependents on it. So, I guess the ratio would probably just be 1. I don't know. My math is terrible. Anyway, it's going to be really stable, which is unfortunate because that's kind of like the core of our logic, right? It's the core of our business. So we've got a problem there where we've got 5 things depending on one thing, which is really stable. And we also want it to be able to change really often, like whenever the database changes. So one way to kind of change those numbers is to introduce an abstract module so that those 5 UIs depend on that abstract module. Now that abstract module is really stable. It's hard to change that abstract module. And we make that abstract module depend on that server project. Am I cheating the numbers?
Wouldn't that still have the same indirect dependency though?
Is that because you count all the fan out as everything recursively, or is the fan out just your direct dependence?
Well, the answer, okay, so you had 1 server project and 5 UI projects, so it'd be 1 divided by 5. So you're getting closer to 0 would be maximum stability, right?
Okay, you're right, yeah.
Yeah, so your answer would be 0.2. But I guess he doesn't really say that you would count indirect.
So it can. So if you think about it, you have modified the equation. So in the case of where you're talking about, let's keep it simple so that you have the 5 to 1, right? You're at 0.2 right there. If you introduce that abstract one in between now you have 5 going into it and 1 going out. So now you've basically got...
you've just moved the stability to the abstract.
You have. But now that makes the...
server side 1 to 1. It's 1 divided by 1. So it would be maximum...
No, it would have no outgoing. The server would then be 0. So it would be completely stable. It would be it would be depended on by the abstract. Right.
So it would be 1 divided by 1. So it would be maximum unstable.
Sorry, it would be 1 divided by 2 because it's 1 over in plus out.
Yeah.
Well, no, the out would be...
No, it's in over in plus out. Or out
it's
over...
out divided by
out
in
plus
out.
Okay, yeah. So it would be 0.
So 1 divided by 2.
It'd be maximally stable. But the problem is...
no, if it's 1 divided by 2,
no, it's 0.5. It's right in the middle.
0.5.
Wait, I thought we said it was 0 over... Man.
No, it's 1 over 1 plus 1.
So that means I messed up my point 2 before then.
No. instability is fan out divided by fan in plus fan out. So
Right.
if that server project doesn't reference anything else, there is
It
no
does the
fan
database.
out. Oh, the
Yeah, the
database.
database.
Okay, I got you.
Yeah. So the database now is fan out of 0 divided by 0 plus 1.
So it's mostly stable. It's hard to change.
Yeah. Yeah. It's really hard to change because it doesn't depend on anything. It only has some stuff depending on it. The server now, because of this kind of abstract shim we've put in place, is now more volatile. So just by adding a simple little kind of abstract module there, we bought ourselves some volatile freedom.
Some wiggle room, basically. Yeah.
It feels like cheating though, doesn't it?
No, but that's what you do, right? Like anytime you need to change something that has been dependent upon concrete implementations, the easiest thing to do is to supplement in like an interface and then just change the piece that was there before, right? So initially, like I guess if you're thinking about an iterative approach to swapping something out, right, without just having to gut the entire thing initially, is everything that was a concrete implementation previously, change that to an interface, a contract that's going to be done, right? And the first step is you put those interfaces in place and it can still use that existing piece there. But now you can easily swap out those things one by one, right? To say, oh, it's depending on, I authorization, right? And now you're changing out your entire authorization thing. So now you can just swap out the back end concrete implementation that was plugging into that I authorizer. And so you're buying yourself that wiggle room. So it is cheating, but it's the way to do it without having to almost full scale redo everything.
Yeah, and without that abstract component there, then as soon as you compile that server, you'd have to compile all 5 of those UIs. Like the computer, the compiler doesn't know any different. By having the abstract module now, you only have to worry about those 5 leaf nodes if the interface between them changes. Or another way of saying it is if the contract between them changes, in which case, well, yeah, of course you do then.
Right.
So it provides a nice little buffer there. It just kind of feels like cheating to me, though. But I mean, that's kind of interfaces are. They just provide a clean line and a contract between two things. So it's just kind of interesting that it changes the numbers dramatically just by kind of inserting that little module there.
Yeah. Okay. So let's go. Let me recalculate then this instability of that abstract component in that example. So that abstract component is dependent on the stable server side, but it has 5 UI dependencies to it. So we're talking about 1 divided by 5 plus 1, right? So 1 divided by 6.
Yep.
Okay.
Yep.
So it's pretty small, which means it's very stable.
Correct.
Stable, yes.
Correct.
Yeah. It means it's hard to change. So when all those 5 UIs were dependent on our server, it was really hard to change the server. But we put that little shim in there, and now it's not so hard. Now it's hard when we change that shim, when we change that abstract module, we've got the pain there. But that should be minimized to only when it really matters.
That almost sounds like, for whatever reason, though, that we're breaking that whole SDP thing where it's got to get smaller as it goes down, because now you introduce that shim, that's 1 divided by 6. Now your next one is 1 divided by 2, so it's 0.5, right? So
yeah.
Your other one was much lower. Now you went down to a 0.5, and now you're going down to a 0 to your database, right?
Other way. So the leaf nodes are all 1s because they don't have any dependencies. They're all...
You draw the stable things at the top.
Right.
So the database would be in the top of your drawing. So when you're going down, you're drawing from the database down.
Oh, I was saying the opposite direction.
But
either way, like those 5
stable things.
No, he's got the unstables at the top.
I'm sorry. You're right.
Yeah.
Putting the unstable components at the top of the diagram is a useful convention because any arrow that points up is violating the stable dependencies principle. And later we'll see the acyclic dependencies.
And that's what's weird is what we're saying is you put that shim in there, it's now 1 divided by 6, and then that's going into a 1 divided by
Well, 1
2.
divided by 6 would be 0.16 or 17, if you depending on how you want to round.
But then if you were going from that shim into just your, I don't know what we were calling it, the server component or whatever it was, now that's one in and one out. So that's 1 divided by 2. So you just went from 0.16 to 0.5, right?
Yeah.
And then you're going to 0.0. So you just violated that SDP principle of everything is pointing downwards.
No, the arrows are still pointing, but the number is not decreasing like you were saying.
No, I think what you're saying is right. So we're saying we've got a 0.17 instability depending on a 0.5 instability, which depends on a 0.0 or 0.
Right.
So what happens is that means we've got something that's stable depending on something that's volatile. So the whole point of us putting that little shim project in there was to bias some volatility, which we did. But that's a bad thing because now we've got something that's volatile being depended on by something that's stable.
And I think really the only reason this is a problem here and what we're talking about is this is such a contrived example in that you would never just introduce one thing. It's never going to be a 1-to-1 type thing when you get down to that level. You know what I mean? Like there's going to be multiple components all depending on that server level. And I think that in real world, you would see those numbers play out better. I don't think that you would ever introduce just a 1-to-1 mapping of all the interfaces that a UI is going to have into the server project. You know what I'm saying? So I think that those contrived numbers are probably muddying the waters here a little bit. But yeah, it shouldn't.
We're sorry, dear listeners, for going into like arguing about these numbers and stuff. It's got to be really confusing. But this has actually been really eye opening for me, and it actually makes me really happy that my little cheater solution there is violating one of these other principles. So even though it makes the numbers look good in one way, it's actually causing another problem, and it's kind of in evidence there and can be detected by static analysis, who can say, "Hey, the numbers go smaller, smaller, bigger, smaller. What gives?"
I mean, this actually reminds me of something that we've talked about that we want to do an episode on is the onion architecture. The whole idea is that your dependencies are constantly pointing down towards the middle, right? And that's sort of what this thing is. It's basically anything that has less dependencies are out on this outer ring, and you just keep pointing down until you get into these things to where, you know, basically everything's referencing them.
This book actually goes into something very similar, and they call it the clean architecture. It's like the last freaking chapter. Yeah. But they basically draw the onion and rename it and probably tweak a few things.
Nice. All right.
I think Outlaw's doing some math over there.
Yeah, I think we...
No, it's just, I mean, because I was just going back over that portion of the book where he was talking about the numbers, because where you were getting not hung up on the numbers, but where you were talking about like the numbers decreasing, and it because it wasn't decreasing, that it was violating the stable dependency principle, and in that particular paragraph in this chapter where he was describing that, it was a little unclear the first time that I was reading it because his arrow, the way he drew the diagram, it went in the direction that he wanted, but the arrows went in the direction that he wanted, but the numbers didn't. But
yeah. So I mean, to round this out, the gist of it is this.
I was trying to reread it, is what I'm saying.
Yeah, no, that's fair. Stable means use interfaces and abstract classes. Unstable, use concrete implementations. You can change them as much as you want at will. And your dependencies are going to run in the direction of abstraction. So the further you go down towards those stable items, the more abstract they should be. Meaning interfaces, abstract classes, that type of thing. Even the template pattern.
Another way to say that is like if you expect something to be unstable, then you expect more concrete classes.
Yeah.
But the things that you expect to be stable, you should expect to have more interfaces and or abstract classes.
Yep. Yeah. Just want to say, I am so glad that we're talking about this. Back in the day, I would read a tech book, and then 2 weeks later, I've forgotten half of the stuff, and it just didn't really stick. But kind of like talking this stuff out, hashing it out, trying some examples, seeing how the numbers turn out. Like, I feel like it really helps me kind of sink in. And so we hope we're not annoying you guys, dear listeners, because we love you, and we think that you should read along with us and let us know what you think in the comments or in the Slack.
Definitely.
We're not done yet, though.
So if you've enjoyed our math so far, then let's bring this together with measuring abstraction. So get ready. This is propeller hat time.
It is.
All right. So abstractness equals the number of classes divided by the number of abstract
plus interfaces. Sorry.
Yeah.
Abstract classes or
Abstractions
interfaces.
Abstract classes and or interfaces.
Yep.
Let me rephrase that.
Sorry.
Let me restate
Operator
that.
overloading.
Abstractness equals the number of classes divided by the number of abstract classes or interfaces.
So an example of the abstract module or abstract component where the only things in there would be abstract classes, it would be number of classes would be, say 100, and the number of abstract classes or interfaces would be 100. So we'd have a ratio of 1. So it's perfectly abstract. And the opposite would be if we've got a class library, say like the database library is probably a good one, where we've got an ORM or something. So each class in there is a concrete class that maps to a table. And so there are probably no abstract classes or no interfaces there. And in that case, our number of classes would be, say, 100, and our number of abstract classes or interfaces would be 0. And divided by 0, error. But I'm going to assume asymptotically that it's 0.
Right. So this ratio is another 0 to 1 ratio. 0 implies that the component has no abstract classes at all. And 1 implies that the component only has abstract classes or interfaces.
Yep.
Yep. And now what's really cool is we can chart these two numbers. So they're two ratios, right? And they're two percentages, call it. We can graph both of these on a simple kind of Cartesian XY plot and get a really nice point on a chart that represents our component.
And so let's try and describe this chart real quick. And we might have to draw a picture on the notes. So it's a pretty simple plot. If you think about it, you're only dealing with 0 and 1. So on
an XY graph.
Yes. On your y-axis, you have your abstractness. On your horizontal x-axis, you've got your instability. All right. So 0 is completely stable. 1 is completely unstable. On your abstractness, 0 is you have 0 abstractness, 1 is you're completely abstract, right? So again, your abstractness on the left, your instability on the bottom. All right, now here's what's interesting. If you go to 1 or 0, 1, which would be, the top left of your chart, and you drew a line diagonally down to the bottom right of your chart, you'd be at 1, 0.
Wait a minute. Let's put some words behind those numbers. So if it's at 0, 1, it's in the upper left of this XY, right? It's maximally stable and abstract, right?
Correct.
Yep. And if it's at the
bottom right,
at point 1, 0, then it's maximally unstable and concrete.
Correct. And then this line down through the middle of this chart. So if you think about it like a square now, your 0 to 1, 1 square that you've got there, you've got that diagonal line from the top left down to the bottom right. That's called your main sequence. And this is kind of where you want to be for the most part. All right. Now, if we talk about the bottom left of that chart, which is 0, 0, this is basically completely not abstract and completely stable. Correct? Yes. Then
right. So it's concrete and stable.
Concrete and stable. This is called the zone of pain. And the reason this is the zone of pain is because it's stable, meaning there are many dependencies on it, but it is completely not abstract and it's all concrete, which means it is incredibly hard to change. So
You've got no buffer.
No buffer whatsoever. You have zero wiggle room. Changing this thing means that you have to change every dependency that is hooked into it all the way up the chain.
Yeah, so just a quick summary of how he defined the zone of pain at 0.00 is highly stable and concrete component. It is not desirable because it is rigid and cannot be extended because it is not abstract, making it very difficult to change because of its stability.
Yep. So going back to what we talked about earlier, if you write code, and let's talk about typed languages because it's the easiest to sort of box you into this, is if you have a concrete class, let's call it person, and you change that class from first name to first underscore name, everything that relies on that person implementation now has to change how they reference that first underscore name. Everything up the chain, right? If instead that thing is an interface and we call this thing iPerson, and iPerson is fulfilled by .first name, then it doesn't matter what that concrete implementation underneath it. That person class could change the underscore first name, but when it returns something back for first name, it'll have to map that first underscore name to the interface first name. And that's why you get the wiggle room, because that interface is what everything else knows about. They don't care about your concrete implementation. And that's why this is called the painted zone. If you've got only concrete implementations, then everything's tied directly to it. There's no way to get out of it.
So 0, concrete, and stable is the zone of pain. So what a better alternative would be is if we are really stable, then we want to be more abstract. This would be 0, 1, and it's right on that main sequence line that Alan mentioned in the top left there. So, if we're stuck being stable, we have a lot of dependencies and we need those dependencies on us, then we want to try and be more abstract. Alternatively, another way of kind of fixing that problem would be to get rid of those dependencies. In that case, we say it's okay to be more concrete, but we need to have less dependencies on us. And that would move us towards the right side, the bottom right side of that square. And that's also another point on that main sequence there.
All right. And this is where things get kind of funny. So now we've talked about everything from the line on down to the bottom left, right? Now let's talk about what's up in that upper right-hand corner, which is completely abstract and 100% unstable. This is called the zone of uselessness. And I love this. And we've talked about this in the past when we were talking about solid, Joe. You remember, you're like, you have 5 billion interfaces and,
right.
And nothing actually does anything, right? This is called the zone of uselessness because if something is 100% abstract, but there's nothing dependent upon it, meaning if it's 100% unstable, meaning there's no dependencies, why you have all this abstractness? It doesn't mean anything. It doesn't buy you anything. There's nothing using it. It's a waste.
Well, another way to say this is you have a bunch of interfaces. Let's say you have a component that's nothing but interfaces, but nothing uses any of those interfaces.
Right.
That's in this 1 zone of uselessness.
Yep. And so, and they call it the software that inhabit this region are detritus. Right? That's awesome.
I really enjoyed that. Yeah. I actually had a hard time kind of imagining this happening in practice, where you would end up with something completely in that corner of the zone of uselessness. But I can very much imagine very easily something ending up at that 0 zone of pain, where you have like a core library, which is dependent on by everything and is full of concrete classes. But the opposite, where it's like a UI that's only interfaces, like, how does that happen?
Yeah, I mean, I think it can happen only when people go crazy, right? Like they learn about interfaces. They're like, interface all the things, right? That's where you end up in that top right corner. But I would agree. You're more likely in any business environment going to see stuff in that bottom left corner a lot. Right? Just concrete implementations where people didn't use interfaces, any abstraction whatsoever, and you're just sort of cornered, right? Like it's one of those things where you cringe every time you have to change that code.
Yeah. And zone of uselessness is like, when do you change those interfaces? Like nothing depends on it. So it does, like you can changing it's completely meaningless. But there could be a case where, like, say your static analysis covers your code, but you provide your code online or something or whatever to some third party that actually consumes and uses those interfaces. And so maybe it does make sense, and it just kind of looks a little strange on static analysis. But that's unfortunate. How do you keep track of, or how do you chart like what you're doing? If you make a mistake or something, how do you even know if you have nothing consuming it? So maybe you should build at least like a reference implementation or something, or throw it in the static analysis there to keep you, accountable.
Independ, SonarQube, there are many options.
Yeah.
Yep.
So, one thing that I was just kind of like thinking about is one of the things you guys said was something about like it was stable, maximally stable and maximally concrete.
Yes.
Right.
Zone of pain.
No, right? Because the zone of pain was
stable and concrete. Yep.
It's really confusing because the I is
highly
instability
stable and highly concrete.
Yep.
Never mind.
Yeah, it's this one. I really hate that it's instability, and this isn't a concept invented by this book. This is something we saw in the end-to-end graphs too, where instability is graphed on the bottom. So a 0 of instability is the bottom left, and that's the same as saying stable. So you're constantly tempted to say stable, which throws you off with the numbers, and even talking left to right is confusing because of that. But the graph is actually instability, so the left is more stable.
Yeah, it's like when you're looking at code and somebody says something not equal false, and you're like, "What? Well, hold on, wait a second."
Yeah, that little knot is so confusing.
What did you do?
Right, not or bang bang object.
Yeah,
and you're like, wait, what did you just do?
You did, huh?
Okay, so let's talk about this now. Now that we've drawn a graph and we're able to create a scatter plot of all of our components on this graph, this very simple, very small XY coordinate plane here, we can talk about the distance from the main sequence. And again, just in case, what is the main sequence? That was the line going from our top left corner at 0, 1 to our bottom right corner at 1, 0. All right. And
that's the good line.
Yeah. So we want to calculate that. So the distance is going to be the abstractness plus the instability minus 1. Wait. Is that a divide? Yeah, that was a divide.
Huh? Is there a divide?
Did I read that wrong? Yeah. No, I'm sorry.
No.
I'm sorry.
Yeah.
Let me rephrase that.
It's just the absolute value of...
Distance is the absolute value of the abstractness
plus the
instability minus 1.
Yep.
Sorry, it looked like a division symbol in the notes.
Okay, so for example, our database project, which we said is firmly in the zone of pain, we'll just say it's got a 0 for abstractness and 0 for instability. So that would be 0 plus 0 minus 1. So my distance from the main sequence is -1. We said absolute value, so 1, which is as far as you can get from the main sequence, or as bad as you can get from the good line.
Which isn't good, because that means you're in one of those bad zones.
Yeah, but in this case, it's it's kind of hard to avoid because database project is just kind of like that. It stinks. But it's just kind of a way to show you like that's the furthest away you can get, and it's going to be a 1. So one of our UI projects where I would expect it to be much more concrete and much less stable. So it's going to be much further towards the main sequence. I would expect it to have a distance of, say 0.2 or 0.3 because there's no dependencies on it and because it's heavily concrete. So I would expect those guys to get better scores. But you can kind of imagine, like, if you took all the projects in our example there and graphed them all, we get a bunch of little dots. We'd have one over there in the zone pane for the database because it's the worst. The server would probably be not so great too because it doesn't really have a lot of reason to be abstract, so it'd be fairly concrete, but it have a lot of dependencies on it. So that would say, I'd say probably would be 0.5 on the stability and abstractness would probably be, like say a 0.1 or something. So the distance from the main sequence then, would be, 0.3 or something. So it would be a little bit further away from that line. And so it's got kind of a less good score there compared to our UI components, but it's much better than our database server. And it's pretty cool if you could just kind of imagine all those guys plotted there to be able to kind of see like overall like how we're doing. And you could take a look at those outliers and decide if you're okay with them or if you want to try and do something about it.
Yeah, so you can even do like how many standard deviations is your score away from that main sequence line, right? And so you want everything to be near that main sequence line. So you want it to be within one standard deviation away from that main line.
Did they say 1 in here?
Well, I'm just saying, like, wouldn't you want it to be within one standard deviation? Like, why?
I don't remember what
you want it to be close to the line.
You want it to be close, but if I remember, I mean, this is going back a while to statistics, but 2 standard deviations is typically like the threshold for most acceptable
stuff falls in a normal distribution.
In a normal distribution. So anything outside of that would typically be bad. Because I want to say that 1 standard deviation is like within 1.4% or something. Like it's really close. But anyways, yeah, I mean, you can use statistical analysis on this and figure
Wasn't
out.
it like 66%, I thought?
I think
that's what I thought.
86.
The magic number.
Man, I can't remember.
But that's only in a normal distribution. And
Right.
I don't know that we're saying that we should have a normal distribution, especially if we're only talking about number of components, because you can have a database component, which is way bigger than, say, your server component, or maybe vice versa. The server component is much bigger than a database component. And so having those as each individual dots doesn't really give you a good picture of how important those dots are.
Well, what I was trying to say though is that like if you okay, so bell curve standard deviation, then that's where we get into like the 68, 95, 99 rule, right? What I'm saying is that ideally, if everything is on that good line or near that good line, right, then you're going to be within that first, 1 standard deviation away from it, right?
Yep.
That's where you'd like to have the bulk of your code. And if you're within the 2, you're still okay. It's the things that cross that threshold of the second of 2 standard deviations away from it. That's when you're going to want to compare. When you see things that are closer to that zone of uselessness, you're going to have to question like, wait, why do I have that? Is that a mistake?
Right.
Is that just code that we left in there by accident? Why is that there? And then the things that are in the zone of pain are going to be the things like the database that you're going to have to look at and go, well, okay, my hands are kind of tied there. What am I going to do?
And even then, even if you start looking in, like at least in the chart in the book, like they just have sort of outliers in that second standard deviation. If you get into that situation where there's just a couple of things lying out there, then maybe those are things that you take a look at and say, hey, what can we do to make this better? Right? Like, I mean, there's no hard, fast rule here. Like they even go into mapping these things over time, which is interesting, right? Like if you have like you said, you have a static analysis tool. And the reason you have that thing is because you have this updated chart of what does my stuff look like? And so you could say, hey, wait a second, this project that used to be in pretty good standing all of a sudden dropped out here. We probably need to investigate what we need to do.
So circling back to one of the comments from earlier in the show, if you include these tools in your build pipeline, then you could be charting this number over time, as you were saying or suggesting. So, you could track the stability of your component over time. And as you see that it becomes more stable and you didn't intend for it to be, then you can start to see like, okay, well, what actually happened? And now, because you have that in your build pipeline and you can see that visually, then you can go back and trace like, okay, what code was introduced at that time in that build that started creating this problem.
And you can now action that as well, right? You see that it changed. Oh, well, we need to introduce some interfaces here. Or we need to drop in some abstract classes or whatever. And yeah, I mean, it's pretty cool. Like having those tools available nowadays is amazing because it can really help you round out some of these things.
And we keep saying independent, but I mean, SonarQube would be just as well. And in fact, SonarQube supports
cross
way more languages.
Yeah, independence for .NET, SonarQube will handle tons of stuff.
It's for everything.
Yeah, and I think it builds or it hooks into things like Jenkins and other build pipelines as well.
Well, check this out. So I was just about to say, like, what would be a cool kind of exercise to do would be to look at some open source project with some of these static analysis tools and see how their components line up. And then I remembered that I'd done this a couple years ago and actually wrote a blog post about it. And so I'm actually looking at, I put a link in the show notes if you guys want to take a look. I'm actually looking at a graph of exactly what we're talking about, abstractness versus instability. And the one I put in the blog post was actually SignalR, though I think I did reports for all of them. And so I'm looking at SignalR. If you're not familiar with that, it's basically, what do you call it, like a real-time kind of WebSockety library in .NET.
Yep.
I think that's about fair. And so I can see that their core library, just called SignalR, is very unstable, which means there's nothing depending on it. It only depends on other things. And it's pretty low on the abstractness. So it's right within that first standard deviation. So it's right in the green zone for that main sequence. And if we look at the things that aren't so much, we can actually see the Microsoft.ASP.NET SignalR core is 2 standard deviations away. So it's got kind of an orange color. And it's starting to drift towards the zone of pain. And that's because it's stable, meaning lots of things depend on it. But it's not very abstract. So still a lot of concrete.
This is interesting. I mean, looking at this, I don't think any of us really knew much about this at the time. But looking at this, the cool part is it looks like they did a pretty decent job creating an application that kept it in this. It's almost like the fat belt that runs through the middle of this graph, right? From the top left to the bottom right. And they did a pretty good job plotting these things in the right spots.
Yeah, and it's actually really hard to read the graph because so many of them fall right on that main sequence line, right? And actually, in their case, it's highly unstable, meaning that these are probably client libraries for various different pieces, and they're also very concrete, which is right on the line. And it's funny, they do have one item squarely in the zone of pain, and it's actually a JavaScript test library.
Yeah, unit test, which makes sense.
Yeah, it's what you'd expect, right? So it's highly concrete, but nothing depends on it.
Yep. No, things depend on it.
Everything depends
on it, but it's highly
so
concrete.
That's weird then. So why does everything depend on a test library?
Yeah, there really shouldn't be much depending on that.
That's kind of weird. So yeah, I might have bundled in my, like tests or something else that doesn't really make sense to look at with static analysis, but it's kind of cool.
Yeah, that's neat.
Well, you could open up an issue with them and point this out.
Yep.
Your stuff's broke.
This is actually a pretty cool, there's another graph in there of SignalR. This is a pretty cool blog post, not to tout my own horn, but this is pretty cool. And a lot of it deals with this kind of stuff that we have just been talking about. You can see a dependency diagram and stuff, and you can see some really nice pictures in this blog post. So we've got a link in the show notes, and you should check it out.
Muchos gracias. So,
and I think I actually, sorry to keep cutting you off. I put links to the actual reports it generated for the various projects in the post. So you should check it out. It's pretty cool.
Yeah. So one last thing to close this out was there was this one statement that he says that I really liked, which is that these metrics are imperfect at best. And I think that's important to always remember, we try, but just because something is in that zone of pain doesn't necessarily mean that you did it wrong or that it's awful, right? This metric can't necessarily reflect the usefulness of your code or that particular component. And so that's what I took away of we're trying to figure out a way to quantify the quality of the code, but don't take it as an absolute.
The quality of the code for being able to maintain and build that code over time, right? That's what this whole thing boiled down to. And that's what I think that's for a lot of programmers. I think the important part here is we all sort of take pride in our code, right? Like we like to write good code. We like to write code that we can come back to and be happy about. But that doesn't necessarily mean it was painless when you were working with other code and other projects and all that kind of stuff. The whole point of this is to think about components in an application's architecture and how can these things fit together in a way to where they're not painful over time to keep building on and expanding and all that kind of stuff.
Well, if I could, so there's this guy named Joseph Zach that wrote this blog article, and there's a quote that he has in here that says, "The worst code I ever saw was the code I wrote 6 months ago," said every coder ever.
Yeah, exactly.
Nice.
So, yeah, man.
I was actually looking at reading through the article. I'm like, I don't really know how to calculate this stuff because some of my code shows as a highly unstable, and my code's pretty dang good. So now I know that like all that meant is that there was stuff depending on it, and it was concrete.
You know, one thing that was a question though about this is that clearly the guys from Independ and Uncle Bob, as they were creating this chart and doing all this math, like this was apparently a known thing because here's two different sources that did the exact same thing.
Yeah.
But, I never really heard a lot about this outside of things like that. Like independent conversations or this book.
Oh man, that link that we're sharing that Joe did a while back from the Independent, that is the chart. That is the exact thing, right?
Right.
Yeah, you can even see the standard deviations, which I didn't know at the time. I just thought they were like cool, flavors of Neapolitan ice cream.
Well, they're that too.
Aren't they always?
Yeah.
Yeah.
Oh man. That's
and the Independ blog actually has a diagram of the Independ code, and like it's really good too. It's only got a couple which are in the second standard deviation closest to the getting close to the zone of pain, but pretty much right down that main sequence.
Cool.
Yeah, I mean, even Scott Hanselman has another article that's similar that was talking about the same zone of pain. His graph was much different with a lot more in the zone of pain. So maybe
I just Googled zone of pain of uselessness, and I'm like mostly seeing Independ articles.
Yeah.
I mean, did Independ invent this?
Well, you can just search zone of pain graph, and you'll find a bunch of if you
Hanselman's articles from 10 years ago.
Right.
And he talks about Independ.
Independ, he does.
Yeah.
Yeah.
So, yeah, I mean, this is stuff that is worthwhile knowing about. Again, going back to all this, like if you're listening, obviously you care about getting better at what you do. And it's nice to think about these things, not just in terms of your classes, but how these things all fit together in the end. And that's that'll make us all better in the long run. So
with that, we will include, obviously, a link to the Clean Architecture book in the resources we like section. And we head into Alan's favorite portion of the show. It's the tip of the week.
Or month.
Whatever.
All right. It's your first. You go first.
Oh, okay. So, I feel like a lot of mine have been on a Microsoft path here lately. And so keeping with that trend, aischool.microsoft.com. So you've seen your Coursera classes, you've seen your Pluralsight courses, Udacity, whatever. So now Microsoft has a AI school with a bunch of modules that you can go and watch, similar to how you would on a Udacity or a Pluralsight. There's a bunch of courses out there, and you can learn how to use, it can start basic with using Python for data science. It can get into, explaining deep learning all the way into hands-on, like, hey, let's use the cognitive services within Azure to recognize faces, or, getting started with using the Azure machine learning site, right? So there's some great modules out there. I thought I would share that as a link, as a resource.
Man, how exciting is it nowadays that you can come to something like this. Like just on the first 3 pieces on this page, this is all free. There is a 2 hour and 50-minute course on a beginner thing. There is a 16-hour module for beginners to completely learn artificial intelligence.
It's an introduction to artificial. You won't completely learn it. It's just an introduction.
Then learn analytics, a 16-hour and 45-minute. Like we're talking about things that back in the day you spent thousands of dollars.
Yeah, man.
To even get your hands on it.
Like you could get a really awesome,
head start,
computer science type education without ever stepping foot on a campus.
Yeah, man.
Nowadays, there's so many resources out there.
It's amazing. This kind of stuff is exciting.
And what that's going to mean, though,
right.
I think that's going to like up the expectations, right? Like if you are going to be in those schools, that's what I would think. It's like because the thing is, as something becomes more available, right? Then it's just expected that you have it, right? Like cell phones became more available, right? So it's just expected that you have a cell phone.
Yeah.
So if you're going to be into computer science and like, it's just going to be more expected. Like, oh, of course you can like find out how to do that because there's so many resources out there to do it.
And even if it's not, man, just having this stuff available. I mean, you could be a step above or a step in front of everybody else if you took the time to, kick back and watch some of these things and try them. So that's a killer resource.
Yeah. And the skill levels, they go from beginner to intermediate to advanced. So there's a ton of the beginner ones in there, but there are some that are in there that are advanced. So have fun with it.
Killer. All right.
Yeah, and what's funny is things have never been easier to learn, but there's never been higher expectations. Like I got my first junior dev box, they were like, make this div blue. And right. I did, and they're like, "Oh, you're hired, buddy." So things are a little different. But then again, think about it this way: like that was not easy knowledge to come by. Like I had to piece that together, by buying a book at Barnes and Noble and working through a couple chapters and whatever.
and looking at with source code of other websites that actually had a blue div.
Yeah, that's right. All sorts of cheating. But with that same level of effort, say they call it a couple hours, that used to take me to get that div to be blue, you can spend that 3 hours learning, introduction to machine learning or to AI or whatever.
It's crazy.
So
right?
That's pretty amazing. And would you rather spend 3 hours to make something blue or just spend 3 hours to learn how to detect whether something's a hot dog or not?
Now here, let's put it into a different context because like obviously we only talk about this as it relates to things that are in like a computer science-y, computer engineering kind of world. But I mean, same is true for anything else.
Everything, man. You want to learn something about finance?
You want to learn how to be a plumber?
Right. Yeah, go to YouTube.
Right.
Yeah, it's amazing. I love the.
That's 1,000 years ago. You're like, okay, I want to be a farmer. They're like, all right, day one, here's a shovel. Start digging.
We've almost gotten to the point where the Matrix is reality, where it's like suddenly like I need to know how to fly an Apache helicopter. Okay, there it is.
Done. Yeah.
Yeah. Zap zap.
It's amazing.
We're almost there.
I'm watching the video right now.
All right, so mine is actually something that my buddy Nicholas that I work with, he shared with us, and it is called QuickType.io. And what it allows you to do is in a number of different languages, paste in some data, and it'll create the classes for you. So if you have a JSON blob, you can drop that thing in there, and it will create you a C# class, probably Python, Java, whatever. Drop some XML in. It'll convert it into class type information. So
now, didn't you give a very similar one that was within Visual Studio that did the same thing?
Yeah, a long time ago. It would take XML.
I thought it did XML and
JSON, and it would turn it into C#, but it was kind of ugly. I mean, okay. I left it as a tip, and I tried it a few times, and I wasn't as happy as I thought I'd be.
But this one created good, clean code?
This one looks really nice. Yeah, this one creates some pretty stuff.
And you can pick the out language?
The out language. So, like right now, I'm looking at there's a JSON blob, and you can have it convert to C#, Go, C++, Java, TypeScript, Swift, Elm, JSON schema, or simple types. So... yeah, man, it's
nice.
It's really good stuff here, and the input types are JSON, multiple, or schema. So I think I'm pretty sure I saw some XML that worked with it. So yeah, really cool stuff, man. Somebody took time to build this little app and free. Go try it out.
I like that.
I keep finding myself doing more and more stuff on websites rather than using apps or even stuff on IDE. Like even calculator stuff now, I just tend to search it and get the answer from Google rather than like opening up the calculator app.
Yeah.
I don't know why.
Well, I mean, I'm very much like that too. Like back in the day, in Sublime, you would install all your favorite like JSON formatters and XML formatters and things like that. And now it's like, I just go to the web. I shared a tip about JSON formatters a couple episodes back. I don't remember how many it was, but yeah, I do that. So now I just go to that website.
Yep.
I think it was like Curious Formatter or something like that. I Google it.
I love these utilities. Yeah. I mean, people all had what was that? People all had a need or something that was, that was bothering them. And so they created these utilities. I actually thought about something the other day. So our buddy Ryan, who
so they're very stable.
They are very stable.
A lot of dependencies.
He wrote Glyphrend, which has now gotten ridiculous number of downloads. But he created the plugin that allows you to find, icons or images that were from Font Awesome and various things in your IDE. Think about this. Anytime you have to Alt Tab out of something you're doing to go get something to augment something you're doing is probably a good idea for some sort of plugin or some sort of utility. So for anybody that's looking for a little project to do, there's you something to think about.
As if you didn't already have enough things to do.
That's right.
Right.
Machine learning.
Yeah, people ask all the time, like, what's a good idea for a small project or learning or something? Like, hey, make a calculator plugin, make a calculator website, make a whatever.
Yeah.
Command line.
Little stuff. Hey, it doesn't have to be big.
Yep. It can still be really useful.
Yep.
Speaking of useful, my tip is a new app that I just started using called Habitica. So it's new year, 2018. I'm trying to develop some new habits. So I kind of looked for some like gamifying apps that I could use. And if you're watching the video, probably not. This is a cute little picture. So I've got like a little role-playing game character on here. I made myself look like a wolf, I think. And I get points for doing little daily tasks that I set up, as well as some bigger to-do list type things. So today I lost a little bit of health because I had not a very healthy lunch. I didn't do cardio. I didn't do 10 minutes of cleaning. I did walk the dogs. I did floss. So, I got some points for that. So these little things I just kind of check off. And so it's kind of a fun little thing. Whenever you go in to check something off, a lot of times I'll notice like, oh, well, I walked the dogs, but I still haven't washed the dishes today. Let me go ahead and do that. And so it's just kind of gotten this kind of cool little rhythm where it kind of encourages you to kind of think about the little stuff you should do.
So
I did not schedule the dentist. So
it's gamifying the habits or to-do list in your life. Yep. So the things that you want to be good habits, you're gamifying it.
Have you saved the princess yet?
No, actually, there's also a little quest you can do with other people. And so one of the incentives is like, well, I want to level up and get stronger and earn money so I can go buy a sword so that the three of us can go, take out the big, Minotaur boss or something. And so I don't think there's any like actual fighting component, but it encourages you to kind of build that power by doing stuff every day.
But this is all
right kind of stuff.
This is all on the honesty scale, right? Like,
yeah, oh yeah,
you could totally hit a button and said, "Yeah, I've lost."
Yeah, I mean, you beat the Minotaur. It's not gonna, give you a sandwich or anything. So yeah, there's not a real strong incentive to cheat either, unless you're just trying to kind of make it look like you're doing better than you are.
Well, isn't that what Facebook is? I mean, like 90% of people
that's true.
Facebook.
That is true. So yeah, maybe I won't add you guys as friends on here then. Fine.
But I ended up using this 12 miles. Sorry.
Yeah.
Only 12?
I ended up going with this one because it looked cute. So it looked like a cute little video game. It's also open source, which I thought was really cool. So you can go contribute to it. And it's on Android, iOS, and it's totally free. And you can actually, I did support the developers. So I look like a wolf because I I clicked the little option to buy developers a coffee and they give me, some money for skins. So that's totally optional though.
Cool. Hey, speaking of Android and iOS, didn't you just recently make some sort of life change?
Yeah, I switched to Android because, headphone jacks, and I had noticed that my computer had gotten, or my iPhone had gotten suspiciously slow after a latest update. And this was before all that stuff came out about the battery. And it may not be related to the battery, but it was like, hey, I updated. Now my life is miserable. So I've still got it here. If anyone wants to buy it, it's got a cracked screen.
How much you selling it for?
Whatever Google says it's worth.
Oh, come on, man.
What did
you want to buy a busted iPhone?
You had a 6?
Yep, 6.
Yeah.
It's not terrible. I haven't had an iPhone in a while. It's another music player device in my house.
Yeah, sure.
We'll talk offline.
Need one of those.
Awesome. All right. Well, I think, was that it? Yeah.
Yeah, just a quick summary. We talked about component coupling. We introduced 3 new principles: the acyclic dependency principle, stable dependency principle, stable abstractions principle, and we talked about stability and abstraction and how to graph things, which can be a little confusing. But if you go to the show notes, we've got a couple of examples we can point you to of what this looks like, and you can kind of wrap your head around it. /72.
All right. So with that, subscribe to us on iTunes, Stitcher, and more using your favorite podcast app. And be sure to leave us a review by visiting www.codingblocks.net/review.
And we forget this every time. If you guys would like some stickers, send us a self-addressed stamped envelope to codingblocks.net/swag. And also, while you're up there, check out our show notes, examples, discussions, and more.
Yep, and send your feedback, questions, rants, to the Slack channel, or hit us up on Twitter or some other way. If you find us anywhere and just ask us, we can point you to where we'd like for you to go.
Way to be definitive.
Yeah, it's kind of a raw deal for you, really. So anyway, hit us up and we'll tell you what we want from you. That would be fantastic. And at Coding Blocks is a great way to do it. Or you can go to the website and find lots of show notes and stuff. Social links.
That is a wrap on a very short show.